Hello everyone, it's Dmitry Anoshin and Surfalytics. This is still Model 1. This is one lesson that I wanted to create for a very long time, and I just myself personally very interesting to learn more about history of approaches, of like some fundamental knowledge, where it's coming from. So hopefully I collected some bits of this information and I can share with you. So I tried to cover around like 30 years of analytics, data engineering. Back in the time, there wasn't any word like analytics. Maybe analytics exists, but data engineering definitely not. There was just databases, there were custom applications, and so on. So the goal is to trying to go through like 30 years of experience, not mine experience, overall experience in the industry, and see like some bits and some examples what exists in the past, what exists now, and what we can expect in the future with the rise of generative AI and large language models. By the way, don't forget to like the video, don't forget to share, leave comment. So in the overall idea, there is the course, the free course, getting starting with analytics and data engineering there. I want to cover as much as I can, as much as I know. And for some people who very interesting to leverage their career, to bring it to the next level, to get competitive advantage, they can subscribe to Surfalytics memberships, where we do the projects, we run mock interviews, the coding interviews, practicing the questions for interview, know the salary ranges. So you will cover from all points for your successful career. Okay, let's get started. So cloud. The cloud computing was happening almost right after Hadoop. I started to work with the cloud maybe 2013. Yeah, but AWS started way earlier. So what is cloud computing? Yeah, because I'm an expert in the cloud computing, teaching like for several years in university, Azure and AWS and the cloud computing fundamentals. And I have lots of different funny memes about cloud computing. Using your laptop in airplane, it's technically cloud computing, but it's not, right? And another one, what is cloud computing is there is no cloud, just someone else's computer. And that's true. Basically, the cloud computing, it's like utility, right? The same as electricity, the same as hydro. It's utility based. You use the water, you pay for the water. You use electricity, you pay for the electricity. With the cloud, you're using resources, you pay for resources. Usually, like traditional data center or hosting that give you empty server where you can host something, your website, it's not the cloud computing. So basically, the cloud is not just the hosting, right? It's how you track the cost, it's how you access it, it's about elasticity, and there are many attributes related to the cloud computing. There is another fun things, right? Everyone thinking about how they should migrate from on-premise to the cloud. And there is Gartner hype cycle. We see 2010, the cloud computing was on the top. Probably the same as now is AI. The key milestone, mid-90s, big giants like Yahoo, Google, Hotmail, Gmail, and so on, they really taken on computer utilities, right? What I just mentioned. And we can think that the start of original cloud computing is 2006. Then AWS launches EC2 instance, Elastic Computing Cloud for renting computer power. We see the Google trends for the cloud computing. We see the market share because AWS was started for the first. Obviously, they took the biggest advantage on the cloud computing. And then there is Microsoft, then Azure, there is in China Alibaba. I think Alibaba even available from North America, but I don't think anyone uses it. There is IBM, Oracle, Teradata. There is also available open source products for building your own private cloud computing. The key terms in the cloud computing is virtualizations, because you have one physical machine and you need to be able to deploy multiple virtual machines. This is virtualization. And this is just example, because there are different types of hypervisors. For example, I can take my laptop and I can install their software like VMware, and then basically it is hypervisor, and then I can host in other operation systems. In data centers, they use different. They're using special host virtualization operation systems, hypervisor, that can host all things for us. And I also in Model 0 mentioned about containers. It's very different for current topic, but just to remind you, the container is just the next level after virtual machines, because the virtual machines usually the heavy. Another term for cloud computing that's quite important is cloud service models. There is infrastructure as a service, platform as a service, and software as a service. This is an example that simplify this. Pizza as a service, right? Who manage what between you as a customer and the vendor who provide you the services. Coming to typical architecture and the roles, it's again my favorite slide, because I like to apply layers to everything I do in data. I build a data warehouse, there's layers. I create the architecture, there is layers. So we can see there is data engineer that responsible for data ingestion, for the data storage. There is analytics part with BI engineers, data analysts, any kind of analyst. Sometimes there is product manager who lead the team, sometimes it's head of the data or anything like this. And also machine learning and data scientists, and with additional layer, I call it technical layer. So it's alerting, it's documentations and data quality checks, data governance, data observability, data ops or ML ops, anything. There's the roles. I even highlight the salary. Data engineer in Canada up to 200K, BI engineer up to 180K, and analytics engineer is between, and salary also like 180 to 100. There is data scientist, machine learning engineer, is product manager. Obviously right now is AI engineer. I forgot to mention, this just how roles is shaping, because in the past we have, for example, ETL developer or data mining specialist, and ETL developer became data engineer. Also with Hadoop we had big data developer, and now data engineer is everything. With ETL developer, big data developer, it's all data engineer. For example, myself, then I started to work as a data engineer in Amazon in 2016. I had no idea what does mean data engineer, because I used to work as a BI developer, and even we never used word engineer, we just BI developer, and they hired me as a data engineer and said, okay, fine, I can be data engineer. And the next thing, what happened, for the next maybe a year or two, I didn't really care about what data engineer means, but suddenly, around like 2018, 17, data engineer became extremely popular. And I was already a data engineer and I'm still doing data engineering, so it was pure luck. ETL facility, because I mentioned about Informatica and their approach of processing data, extract, transform, load, but the modern approach in the cloud is ELT. And here we have little picture, there's transform step that we process the data and load into data warehouse. In the cloud, we want to eliminate this thing. We want to somehow push the data to the cloud storage, data lake or data warehouse or Lakehouse or anything. Usually in between exists extra step that we can see this or sometimes not see. It's the cloud storage. AWS has 3 buckets, Azure has Azure storage, or Google storage has also buckets, where we should place the data, and then we can push this data inside data warehouse. Or we can just read this data. The BI market, so we can see how the shift happening from enterprise-grade BI products like SAP Business Object, MicroStrategy. There you need very experienced, sometimes even BI architects role, who can do any kind of changes. Usually they hold everyone. It's like serve bottleneck. Imagine you need to add new filter or dimension or metric. The business users, they couldn't do anything themselves. They need to create the ticket. They need to wait while the BI developer team will take this ticket and do the changes, and it will reflect the semantic model. So a bunch of work. Tableau leverage this from the different perspective. From self-service BI, it means any users can build their own small data source, data model, extract. I don't know, every vendor has their own term for this thing, but they can build their little thing, they build the dashboard and publish. So the speed of development increased, the quality of development decreased. Right? If anyone in the organization can build their own revenue metrics, which one to pick, which one to write, right? And there is Gartner, there is the Forrester, just telling that Microsoft with the Power BI and analysis service almost gone. There is also Fabric, they're quite popular. And my assumption why they're so popular, not because the Power BI is greater than Tableau. No, I personally hate Power BI and I really like Tableau or Looker or anything outside Power BI, I would say. So, but imagine if every organization, since I don't know, Windows release, the very first Windows release and the very first Microsoft Office product release, it's basically Microsoft organization has reached to almost every organization on the planet. And they're running either Windows or Microsoft Office. Obviously, if they have really good relationship with Microsoft, they can start using their Power BI product. And sometimes the customers buy some bigger and more expensive solutions, and they get complementary Power BI. And also for the users who used to work a lot with Microsoft spreadsheets, the Power BI just feels more natural for them. I don't blame them. They're really enjoying the product and the product really powerful. I just not really fan of the Windows systems and the Power BI and how the things works and their interface. It's maybe my personal choice, but the bottom line, Tableau, Looker, Power BI, the most free popular BI tools that you need to at least try and understand. One of them you need to know really well. This example of open source BI, it's another category, and right now we have rise lots and lots of open source. For example, Hadoop is open source, Spark is open source, and there is Managed Spark, Databricks, there is Apache Superset, there is Redash, Metabase. Those products that I put here, they for BI, the open source. And there is also debate and trade-off, what's better, what's worse, then we talk about open source. So this example of Microsoft Power BI dashboard, example of Tableau dashboard. Cloud brought us lots of data warehouses, starting with Redshift. I think Redshift, the same as I believe, Hadoop really pushed the big data industry, built the ecosystem of different tools. Redshift did the same for cloud analytics and data warehouse because it was the first very clear cloud data warehouse. By the way, it's platform as a service, PaaS. Now you have the managed SaaS Redshift, and now you have managed everything. We'll learn more about distinctions of those tools in the future. But here I want to highlight that Redshift was really power everything. There is a really nice chart from founder of Fishtown Analytics or DBT Labs about how Redshift, based on the release of Redshift, how it triggered all the things in the cloud. There's Looker, there's DBT, and some other cloud products that build around Redshift Cloud Data Warehouse infrastructure. It was default choice for organizations. They want to build data warehouse in the cloud, they're going to use Redshift. Right now you have way more options with even DuckDB, the Lakehouse, and yeah. There was Firebolt in the, I don't know, Firebolt just gone. I don't know. Did they fail? Did they, somehow they were very promising, but they gone. So the Snowflake was really next big thing. It's the data warehouse as a service. It's actual Lakehouse, but doesn't matter right now. So I just highlight the tools like Azure SQL Data Warehouse, Synapse Analytics, there is Databricks, even Azure Databricks, and then because Azure platform didn't have Spark, they did collaboration with Azure Databricks, and then they released their own Synapse Spark, and then they started chase everyone inside Microsoft to migrate from really nice Azure Databricks that works and support all use cases to really raw dog food Synapse. Yeah, that's what's happening. So manage Hadoop, AWS EMR, Azure GSite, yeah, a bunch of cloud platforms and data warehouse. So, and the last thing, there was, because in the past, we have really clear distinction in the roles. So data engineering, or like ETL developer doing only data warehouse things, BI doing only BI. So right now, all those roles, they're starting overlapping with software engineering, with DevOps. Those skills is important. The more you know, the better you are. And probably the more skills you have that you can apply, and it means your cost and total compensation could be higher. So the next big thing is Lakehouse. So let me talk about Lakehouse. What is it? I will put this slide from Databricks, and I will transfer you to my previous experience. Then I was working in Amazon Alexa in Boston, And we've built a really huge data lake using Elastic MapReduce, managed Hadoop, and Hive and Spark to process large data sets from Alexa devices. Everything was fine, and then we started, it was time then GDPR arose. It's privacy, it's compliance. One of the key things was there is to, based on the customer request, you have to delete the customer information from database. It's very easy to do it from a relational database. You can run command delete from table name, for example, customers where customer ID equals something. And you can just delete the customer ID and all associated records, very simple. From data lake, you couldn't, because data lake, usually you store data in Parquet or maybe Avro or ROC format. You store it probably in partition by date, hour, or something like this. So you couldn't really find all, and it's just the files in the folders. You couldn't find all the files that you have the customer ID. To solve this, you either store last 90 days of data, or you will reprocess all data set and just filter out the customer ID, or maybe you will reload the partition. So it's expensive, it's inconvenient. So Lakehouse, and in particular that time, it was probably 2000, maybe 19, 20, something like this. So the solution was to use Delta Lake. Delta, it was initially built by Databricks. It's open source product. It's the format of file. So we still store the data in Parquet type, but in addition to this, you're able to load the data. In addition to this, you can collect some additional metadata about the Parquet and store in Delta logs. So the solution is you can use the same Spark or you apply the same, but now every time then you write the data, you actually create the Delta log. What it gives you additional capabilities to the data. Some example for ACID, right? ACID stands for atomicity, consistency, isolation, durability. That's really common for relational database, but not for data lake. Those kinds of formats, they give advantage to using these kinds of things. Now you can do the merge statement against your data lake. You can use delete command, update command. So you can start doing all your traditional data warehouse things and running, for example, pipelines for slowly change dimensions, right? That you can want to update the record. Basically, Lakehouse means you take best of data warehouse, your transactional things, your SQL approach, how you store and query the data and transform, and data lake with decoupled storage and compute. This is the Lakehouse. There are three Lakehouse formats. There is Delta, developed by Databricks. There is Hoodie, created by Uber, and Iceberg. So what's happening right now in the industry, for example, right now, because it's summer of 2014, or just finished the Snowflake conference, and they released that they really investing more and more in Iceberg format. At the same time, Databricks acquired Tabular. Tabular was they basically the founders of Iceberg format. It means that Iceberg format take over two other formats. So by default, right now, Delta is the default format in Databricks, but looks like the Iceberg is taking over. And by the way, since we talk about Lakehouse, the Snowflake is a Lakehouse. So it feels for everyone as a data warehouse. And I think they really simplified the marketing offering for the customer and the value added things. So the customers wants to buy a data warehouse. And Snowflake is a data warehouse. But architecturally, it's the Lakehouse. So you have your compute, or the virtual warehouses. It's your compute clusters that can query data. That can query data in data lake. They don't call it data lake, but basically all the data store in the cloud storage, in the data in Snowflake appropriate format. It means for customers it's mostly vendor log. Versus Databricks, you store all the data in the format and type you want to choose. And it means if you don't like to pay Databricks, you can completely decommission Databricks and start using open source Spark, or even switch to the Trino or any other query engine. So with Snowflake, you couldn't do this. The Iceberg, I talk why is Snowflake is a Lakehouse. Yeah, Snowflake is a Lakehouse. It has Lakehouse architecture, but it's hidden because it's data warehouse as a service. It's like a kind of service. Customers pay a lot of money for this. That's why they don't care what's happening under hood. but I just mentioned you what's actually happening under hood. Another big thing that happened in this time, that the most recent time in data engineering, it's the release of Microsoft Fabric. The idea of Microsoft Fabric, because Azure has lots of products for analytics. Initially, for example, then the Azure first released the Azure Data Warehouse that under hood has 60 instances of SQL servers, and it's either logical instance or physical instance, depends on your scale of SQL data warehouse. Same as a Redshift. Inside it has the Postgres engine, right? Open source that they basically starting to improving. And then the challenge was, if you're running multiple products from Azure, for example, you're running Azure Data Factory for orchestration, you're running your data warehouse, you can run DevOps, you can run some other products. The challenge was that you need, for every product, you need to set up and configure independently the security, the integrations, the networking. It was quite a challenge. The Synapse, it was the solution that can help you overlap everything and union all together under the same umbrella of workspace. So Synapse Workspace gives you ability to run your data warehouse, your Spark, I think integration with DevOps, data warehouse, even Power BI. The Power BI feels very independent and very popular. So my Microsoft Fabric, I think it's giving two things. First, it's giving you accessing from Power BI everything you want, like upstream is one data lake. There is like data engineering use cases, BI use cases, so many use cases, and everything available from your Power BI workspace. But also it is true serverless. So you stop caring about how you admin this, how you scale resources. You basically just pay, and you can see with a bunch of services all available in one platform. For me, as I consider myself as a data engineer, these kind of things give it's not good, because for business users who are able to build dashboards in Power BI, they have no idea how to build the data warehouse, data engineering, the layers, the quality, data modeling, and so on. But they have ability from workspace, from the browser, using the mouse, they can click and they can create a lot of resources without understanding how they should work together, what's the best practices, and so on and so on. I think they can build solution. The quality of solution, it's questionable, the first. The second one, the cost of solution, is it efficient enough and performant enough? It's also questionable. But it is what it is. It's just good to know what is Microsoft Fabric is just alternative of a solution that you can use. I'm using Snowflake, I'm using Looker, like different. I personally prefer to use best products and then combine them in one solution versus just go all in Azure and use all Azure resources. Because from skill perspective, if you're using, for example, only SAP solution or only Microsoft only solution, you lock yourself to one platform. Yeah, if there are lots of jobs on the market, with those skills, you're in good position, but you also, if you want to switch, you want to go to another company, you're really limited because you know only one side of the things. That's why, again, in Surfalytics, I try to cover everything and also give you idea and tips like how you can bridge different products and platforms together, because fundamentally, they're all the same. Observability and other big things, it's not new. It's coming from DevOps, but DataOps and data observability is a big topic. Honestly, I like product like Monte Carlo. It's the service, it works really nice, and they give you lots of insights how you can manage the data. You even can just run simple SQL test to check your data quality. There is lots of frameworks that can do it for you. So the last thing, let's trying to talk about what expect from the future, because everyone aware with Generative AI, large language models, and probably the main question, will this thing replace us, like data engineers, analytics engineers, BI engineers, data analysts, or not? I think my answer is not. Right now, the key use case for organizations, because I have exposure to lots of organizations and see what they're doing, how they're doing. Every organization, their roadmap, doesn't matter what they do, their roadmap is AI initiatives. So they want to leverage AI because they don't want to lose competitive advantage. There are use cases with AI, for example, you can optimize your knowledge base or maybe customer service. But one thing what relate to the engineering works, it is productivity and quality of the work. because the things like ChatGPT, copilots, they can boost you. For example, if you're creating the SQL, you can linting it. If you don't know what function to apply and you need to search to Google it, you can ask Copilot or ChatGPT. It can give you really quick answer what function to use and try. If you have the error message you don't want to search, again, you can save lots of time. You can, for example, you're writing the Python code, you really boring to write the documentations. You can feed your code to the ChatGPT and it will create the nice, good doc strings for you. Or like you have the repo with no product documentations, you can feed it and you can produce really nice documentations about the repo. With legacy code, you don't know what it does. Again, you can feed to AI and it can help you. So it's not new because this was developed long time ago, but probably right now they think we can see that OpenAI and they think how things work, because hardware and compute catch up what's happening in the industry. So now company has access to big computing, like in terms of size and the power of computing, and it means that everyone, not everyone, but probably organization can start leveraging and calculate. You see, like this is the number of parameters, like how many features they have to come up with their model. That's just large language models. This is one big thing that definitely influenced the work. Another thing is the vector search, and I like to use like the key vendors, the top vendors like Databricks, probably the number one, who is building the features, and they also provide the trainings and workshops, like free workshops, so you can try. So for example, using Databricks, it means you're using Spark, you build your data lake with Spark. So now you can see how the vector search can help to make it better, your solution. And this is just example of vector search from Databricks. So the vector search is quite popular nowadays, and it definitely will be developed in the future. So you just need to know this term and what does it mean. And the last one is retrieval augmented generation. It's again Databricks example. The thing is, assuming you have data warehouse and you have different use case for the data warehouse, because by default, for example, if you're using generative AI, it's not very helpful because it doesn't have the right context. So retrieval augmented generation, it means you can blend together approach of large language models and your available data. And these systems already will give you the better answers because it has the right context. So that's it. The last lesson will be about Microsoft Spreadsheet. After this, we will move to the model number 2. About databases, we'll learn the Postgres, SQL Server, MySQL, on-premise, in containers, and in the cloud. And we'll start connecting to BI tools. We'll practice in the SQL. We'll find all good materials for the SQL. After model 2, we move to model 3 about all things BI tools, on-premise, open source, in containers, in the cloud. And then model 4 about ETL tools and data integrations, again on-premise, a bit on cloud, and also we'll spend time on dbt and Airflow in particular, since they're quite popular, maybe some other open source. The model 5 is the cloud computing. The model 6 is cloud data warehouses like Snowflake, Synapse, BigQuery, and so on. What else? Model 7 is Apache Spark and Databricks. Model 8 is big data, is Hive, the Hadoop. Model 9 is about Lakehouse, in particular Delta Lake and Iceberg. We'll use the Trina, Iceberg Lake, Delta Lake, and 10 is streaming. Model 11 is machine learning, data science, just enough for data roles, and the model 12 is like best practice and everything. So see you everyone.